I wanted to record something outside today, but seems like it's going to rain, and I don't want to risk with the laptop, so we're staying in today. And show how to run this new model called DeepSeek on your laptop, on your MacBook. It's a really special model. It has learned to self-evaluate its own answers, to come up with its own reasoning, and learn that by itself, not just by copying something else. It can have these very interesting aha moments when it figures out as it's thinking that maybe it has made a mistake and then tries to correct it. There's some distilled versions of this model that perform really well and run quite fast on a MacBook. I've got this document that I've linked in the description below, so you can follow as well, follow along. And I thought I'd show you how to very quickly run this model and then explain a little bit about what's going on. Yeah, the first thing you'll want to do is go install Ollama if you don't have. So I've got that installed already, but you can go to ollama.com, download, install it, and then you will want to open the model page. So that's linked in the description as well. And this is the model we're going to be running today. Here, you've got the different distilled versions of the model, including the actual full entire model. So one thing about this model is that it's fully open source, including the weights, everything. Unfortunately, I cannot really run the giant model on my laptop. Maybe if this video does well, I'll manage to get a farm of MacBooks, and then we'll try again. We're going to pick a couple of them. We're going to run the 7 billion parameter and then the 1.5. I'll explain the difference between these in a minute, but first let's go ahead and run this. So what we're going to do, I'm assuming you installed Ollama, I'm assuming you've looked at that model page, and when you select the model, it will give you a command to copy. So here, so we're going to go 7 billion, and then we copy this, okay? So then we can go to our terminal, we paste that, and that's it. I mean, that's as easy as it gets. So I've got the model installed already, so it's just loading it. But if you're running this for the first time, it will install the model and set everything up for you. So once it's ready, it will have the message interface in the command line. Let's say hello. So now one interesting thing you'll notice is that this model will always output these think tags. In this case, it didn't need to think, but it will still output them. Actually, yeah, let's go ahead and do the common example that everyone does today. How many R's are in the word strawberry? Okay. So, okay, now you can see think. We'll try to figure it out. You will notice that it kind of makes mistakes here and there. Okay, interesting. It's going kind of off in a weird direction. Okay, counting the R's. So, yeah, so that would be 2 R's. So here it's getting it wrong, right? Yeah, so it still got it wrong. I guess this is a smaller model, but you can see that it is thinking. So yeah, it's interesting to see that this one still comes across not so well. We're going to do something else. So by will get it out. And then what we're going to do now is we're going to go to the smallest model available. And we're going to run this one. Okay, so hello, much faster. So you can see this is actually pretty fast. And the fact that the tags are always outputs this way, it means that if you were to interface with this model in some of your scripts, you'd be able to filter out this very easily. How many R's in the word strawberry? Okay, so it's going much faster. I wonder if I have a typo on the previous thing because it got very confused. Anyway, so here is going off doing something really awful. So it's a tiny model. But yeah, the interesting thing about this model is that it can think by itself. Now, so we've done these steps, and yes, it's that easy. So I'll show you very quickly what you need to do to run this from a Python script. Actually, it's pretty simple still. from the same folder, I've already got a Python environment installed and set up, but if you don't, you can follow these steps here in the document, which again is linked below. So I'm just going to copy this and add it to that file. So let's see. So we're going to do ask DeepSeek. Okay, so we're going to copy that code here. So what's happening here? We're using the Ollama model or module. We're running the chat version of it. We want to set the name of the model to be the one we have on the web page. So here, the same one that we used to run Ollama in the previous command. And so if it was the 7 billion, for example, you would write this, okay? You run that, so let's go and run it. And very, very soon, it should be asking the question. There you go. So you've got the answer. So for reference, the question is, why is the sky blue? And let's see why. So it did not think much, I guess. Yeah, gave us some answer. I'm not going to read and see if it is fully correct. But the point is that this model is very, very small, and it runs very, very fast, as you saw. This means you can run it in a few more environments, in a few more machines. So robotics will likely be a good one soon. Some agents and a few other interesting cases. You can also run what we've just done, the Python version, you can run with the OpenAI compatible APIs. So if you've got an application that is compatible with OpenAI, you can swap the base URL for this one, and then you still pass the model name as we've done, and it should work. Then, yeah, if you want to run the full one via the API, DeepSeek also has a good API documentation. And then another thing is you can also go to their main chat service, and you can actually talk to the big one. And this is actually a big difference. So how many R's are in the word strawberry? Oh. But now let's add a trick here so you can see the thought process. As a Portuguese speaker, so let's see. So now this is the thinking step, and it's trying to count, and it will go through this. So let me see. There's an R after T. It's kind of going through that reasoning. Seems to be getting the right response. And then it kind of goes on trying to figure out what I meant by as a Portuguese speaker, right? I've managed to confuse it sometimes where it tries to understand if I'm trying to translate the word or trick it. Many, many times it caught that I'm trying to trick it, and it will tell that back as well. Yeah, so I guess this makes sense. So as a Portuguese speaker, this count remains the same because the question refers to the written letters. So it makes sense. But you can see the entire reasoning and logic that it followed. And that's actually pretty cool. And in this case, so this is running the full model, the full DeepSeek R1, and this is not just because it's a bigger model. What we were running before on our machines is what's called the Distilled Models. So what they've done is they've got two other architectures, in this case Llama, which made by Meta, and I'm not sure how to pronounce, were Quen, which I should have checked, but I forgot. It's based on either Alibaba or some other company. And so these are two architectures which perform well in different situations. So I think Quen is more like for mathematics and coding. I think it does pretty well. Llama will be a bit more general. But what they've done is they've created this new architecture, the R1, and that they use that architecture to generate data to train the distilled models, the smaller ones, so based on Llama and Quen. And what that means is that they're just generating data using the R1, but R1 itself is a different architecture. It's not just being bigger, it's a different architecture. And that is important. So the reasoning that it does is different. And the smaller models that we were running, they were trained to mimic that reasoning, but they're not actually doing it. Why is this important? The distilled models are small, but they're still pretty good, and actually they perform better than competitors of much larger size. The 32 billion parameter, which we didn't run, we ran the 7 billion. So that one is performing better on some benchmarks than even GPT-01 mini. But one thing to keep in mind though is that this is running at a small fraction of the cost of the GPT models. Pure reinforcement learning training, and no human label was involved. At least on their, they have like a few models that they delivered. One of them is the R1, so that one is from scratch trained with this new technique. So that means that the model learns to self-validate and to correct itself and correct its own reasoning, which is quite interesting to see. And you can see the model sometimes get to some aha moments. Leave in the comments if you have questions you'd like to see it tested. I can do some shorts or some other thing, and I can run them for you as well. It performs much better than much larger models. The R1, the full one, is performing better than the GPT-R1 that OpenAI has released. And the part that is very interesting is when it comes to the cost. Here's a little comparison. So the 4.0, which is maybe the most used one by OpenAI, it runs with no caching. If you don't know what that means right now, it doesn't matter, just ignore. But with no caching, it's running $2.50 or $2.50 per million tokens of inputs. And it costs about $10 per million tokens of output, right? So then the O1 is just, a lot bigger. So that will be $15 for the inputs and then $60 for the output. Now look at the numbers on DeepSeek. So we're talking about even less than $1 to run something that supposedly it's as good as the largest one, or at least in many aspects will be as good as the O1. So that's 55 cents, right? And for inputs, and $2.19 per million tokens for the output. When it comes to costs, right now I'm not sure if anything else can beat this, considering the quality. So the dollar per quality is pretty good. Then another reason why this is really important is that it's fully open source, MIT license as well. And this is not just the code, but the model itself, the weights, everything that was trained. If you've heard of this model, you probably have heard of it from the perspective that this is a Chinese breakthrough, and maybe it's kind of getting through the Silicon Valley monopoly of AI development and AI research. So I don't think many people were expecting something like this to happen at this cost. You can run this, even the small one, that still performs pretty well in math and coding somewhat, but this 1.5 billion can still do a few interesting things. It can still do well in function running and tool usage, for example. And it can run on a Mac, it can run on other devices as well. Even the 7 billion is performing as well as some of their competitors on some benchmarks. In my opinion, this could be actually an interesting step towards multi-agent performance, both from an energy perspective, not just the fact that they do well in the benchmarks, but from an energy perspective, from an actual dollar cost, and then from the fact that it can run faster, so you should be able to unlock a few use cases that weren't possible before. Go to this page. Let's do it. And there's a list of things that already integrate with this to some extent, or that use it to achieve some goal. Let me know in the comments if you want something that goes in more detail into how they've trained the model and how the model actually works. But just high level, this is a mixture of experts model, which is along the lines of what Mistral has been doing. And it's 671 billion parameters, but it's running only at most like 37 billion parameters in each forward pass. So again, very performant. That's why you can keep the cost down. So again, it's efficient, and it uses the experts to kind of learn a few different domains. It has had that new training methodology, so uses reinforcement learning, which means that not only it's cheaper to run the model, the inference, it's also cheaper to train. So the training is orders of magnitude cheaper than the competitors and can achieve similar results, if not better in some cases. You can also use that model to create these dense distilled versions. So this is like the Llama models that were trained on this data. Maybe optimize them for specific domains. And you can have models that are smaller and still perform quite well, due to the fact that the quality of the data coming out of the large model is pretty good. The 32 billion distilled model is performing better in this benchmark, which is a mathematics benchmark, than the GPT-R1 mini, which is much larger and more expensive. That's it from this document. I don't know if this works well as a video, and I thought I would create like this very short documents that explaining how to do this quickly, take you through this myself as well. So, and then you can still continue and do it yourself if you'd like. Otherwise, if you, leave a comment if you have any interest on understanding how this model was trained more specifically, or at least going more detail in that and how it works and the differences in the architecture. I'm happy to cover that as well in a different video. If you like this format, or if you don't like this format, please also leave a comment and subscribe. That would be quite helpful. Maybe with some help, if if this is successful, I get to buy a few Macs and try to run the distributed version of the very large model. So I guess that's it. So bye.